Another type of word problem that's newer is going to be bearings. Bearings are essentially directions given when we're talking about navigation. A bearing measures the angle that a path or line of sight makes with a fixed north-south line. So you have to know your north, south, east, and west. So if I look at this first problem here, this says 100 degrees. So I'm going to essentially just draw my north, south, east, and west. So I need to figure out the angle or path of 100 degrees with the fixed north-south line. So if you look at the study tab, it says, in air navigation, bearings are measured in degrees clockwise from north. Examples of them are shown below. So this is a bearing of 60 degrees because it's 60 degrees clockwise from north, and the bottom is 225 degrees clockwise from north again. So I am essentially going to, since there's no other north, south, east, or west direction here, I'm going to start north. So I'm going to essentially, it's like starting upwards on this line here, and I'm going to travel 100 degrees clockwise. So I'm going to travel 100 degrees. So 100 would be a little bit past 90. So this angle would represent a bearing of 100 degrees. Because it's 100 degrees from north and then clockwise. So you can almost think about it as north 100 degrees east. We start at north and then we move 100 degrees towards east. So if I look at the next one, I'm going to just draw my north, south, east, west lines. And this one says south 50 degrees east. So that's 50 degrees east of south. So I'm going to start this one essentially a little bit downwards on my south line. So I'm going to start south and I'm going to move 50 degrees towards east. So that would be essentially a little bit more than halfway. So this angle would represent 50 degrees south of east. So that's the bearing there. The last one says north 40 degrees west. So we want to travel north and then 40 degrees towards west. So I'm going to put my directions on here. So I'm going to start up at north and then I'm going to move 40 degrees towards west. So this would be my bearing, my angle here. So this is the angle north 40 degrees west. Okay. So if I look at this next problem, it says a jet leaves Reno, Nevada and is headed towards Miami at a bearing of 100 degrees. The distance between the two cities is approximately 2,472 miles. Two parts. A, how far north and how far west is Reno relative to Miami? And B, if the jet was to return directly to Reno from Miami, at what bearing should it travel? So the most essential thing here is going to be drawing a picture. You will always start with a north-south line. You can also add in your east-west. So it says that we are flying at a bearing of 100 degrees. So if I look here, there was no direction that went with it. So that means that we are traveling from north and going clockwise. So I'm going to travel from north and we are going to go clockwise. So from north, we're going to go clockwise 100 degrees. So that would be a little bit past 90. So this would be a good angle to represent a bearing of 100 degrees. So I'm leaving Reno. So this starting position is Reno, and I'm ending at Miami. So we want to know how far north and south. So I'm going to have to extend my north-south line here. So I want to know how far north, and then it said, and also how far west. So this would be north, and this would be west. Well, within this picture, I don't know any information besides it told me the distance between the two cities. So I'm going to mark my hypotenuse, the distance between them, as 2,472 miles. So this 100 degrees is outside of my triangle, but the north-south line is a straight line up and down. So if this outside angle is 100 degrees, hopefully you're able to realize that this would be 80 degrees, because together they would equal 180 degrees. Well, if I know an angle and I know one side, I should be able to find those other two sides by using trig. So for part A here, I need to find how far west and how far north we're going. So we're going to say sine of 80 degrees equals W, because I'm doing opposite, is W over hypotenuse, which is 2,472. So W would equal 2,472 times sine of 80 degrees. So W is approximately, if you put that in your calculator, 2,434.4 miles. All right, how far west did we travel? So that we just answered. So the other one is how far north. Well, if you look at the angle that we're given, 80 degrees, that we found, and then we're looking for north, so north is adjacent to that, and the 2,472 is the hypotenuse. So this would be cosine, because I have adjacent over hypotenuse, so cosine 80 degrees equals north over 2,472. So north would equal 2,472 times cosine of 80 degrees. So if you put that in your calculator, you will get approximately 429.6 miles. So we were able to come up with the picture and then set up some trig functions to find those two missing sides. So far, nothing of the work is different, just the picture is more challenging to create. So part B says if the jet is to return directly to Reno from Miami, at what bearing should it travel? So I'm going to kind of zoom in on my picture here. So we're saying if we wanted to go directly back from Miami to Reno, what bearing, what angle would I have to use? So I am going to create my north-south line. And we are going to remember, if we're talking about bearings in air travel, air navigation, we always start from north and we are going to go clockwise. So I need to figure out what this angle would be so I can travel that same path back to Reno. Well, if you look at your triangle, you know that this angle is 80 degrees and it's a 90 it's a right triangle, so my missing angle here would be 10 degrees. So if I look, this is 90. From here to here would be 180, 270, and then an additional 10 degrees. So for part B, for my bearing, I can take 270 plus 10, so I would get a bearing of 280 degrees. So if it doesn't specify direction, you know it's always from north and then going clockwise. All right, so if I look at this next one, it says a privately owned yacht club leaves a dock in Myrtle Beach, South Carolina, and heads towards Freeport in the Bahamas at a bearing of south 1.4 degrees east. So 1.4 degrees east of south. The yacht averages a speed of 20 knots over the 428 nautical mile trip. A, how long will it take the yacht to make the trip? B, how far east and south is the yacht after 12 hours? And C, if a plane leaves Myrtle Beach to fly to Freeport, what bearing should it take? All right, let's get what this picture looks like. So I always start with my north, south, east, west line. And this says south 1.4 degrees east. So I am going to start down at south and move towards east. So, and it's a very small angle. So this angle right here, that is your 1.4 degrees. So I'm starting at Myrtle Beach, and we're riding this boat along this pathway, and we're ending up at Freeport. So now that I have my angle, we want to know how long it will take the yacht to make the trip. So I was given some important pieces of information. I know the speed and I know the distance. So the distance, let's add that onto our picture of 428 nautical miles is abbreviated NM. So how long will it take to make the trip? A speed of 20 knots over 428 nautical miles. So that is another one where we have to use the fact that distance equals rate times time. So the distance is 428 nautical miles. The speed is 20, and we have to figure out the time. So I can divide by 20. So my time would be 21.4 hours. So our trip is going to take 21.4 hours. Okay, part B says how far east and south is the yacht after 12 hours? Well, we're given this time frame, so we need to figure out what the distance is at 12 hours. So distance equals rate times time. I don't know the distance. The rate is still 20 knots, and the time is 12 hours. So now I know my distance is 240 nautical miles. So if I was to draw this picture again, so I'm leaving from Myrtle Beach, and we still have that angle of 1.4 degrees east of south. So that is 1.4 degrees. So now we're going to figure out how far east and south we need to be. So I know that I can essentially create a right triangle. And so we can label the horizontal would be east, the vertical would be south. I just found out the trip is 240 nautical miles after 12 hours, so I can label that my hypotenuse. All right, so I can use two trig functions to figure out E and S. So for E, that's across from the angles, and then I know the hypotenuse, so I'm going to say sine of 1.4 equals E over 240. So if you multiply, you'll get 240 times sine of 1.4. So that would be approximately 5.9 nautical miles. So you are about 5.9 nautical miles east. And then to find south, I'm going to use cosine because that's adjacent. So we're going to say cosine of 1.4 degrees equals S over 240. So S equals 240 times the cosine of 1.4 degrees. So S is going to be approximately south is 239.9 nautical miles. So part C says if a plane is leaving, okay. So if the plane is leaving Myrtle Beach, we just talked about how air navigation is always from north and goes clockwise. So if this is me leaving Myrtle Beach, we want to figure out the bearing that it would have to travel to fly to Freeport and not take the yacht. So if I look here, I need to figure out how many degrees, what my bearing would be from north and then clockwise. So we know that the angle that we traveled was 1.4 degrees south of east. So we need to figure out what would be the bearing if I left from the north and then I traveled clockwise to get this angle to travel this trip to Freeport. So hopefully you notice that together they create a straight line. So the bearing would be 180 degrees minus 1.4 degrees. So that would be 178.6 degrees. Bearings can be kind of challenging for some people. Hopefully we'll get a little practice with